Hello everyone, a very good evening. Welcome to Unacademy, the number one learning app in India that made learning easy for all the students. Hope everyone audible. All right. So this is all about today's session regarding uh, capacitors and even resistors. I will solve each one from capacitor and one from resistor. Okay. So let me recheck once. 1 second. I will wait till all the joiners come for live, and even I will update the chat box here. So go through this Karnataka CET 2021 comprehensive batches. For those people, we have a lot of opportunities. Like if you subscribe for Unacademy Plus, then you will get all these beneficiaries. Complete syllabus will be covered. Tips and tricks are given by the top educators from the part of Karnataka. Topic wise practice questions, full length mock test. So these are the beneficiaries we give for the students. Hope mm, you will subscribe for Unacademy Plus as soon as possible. That may help you a lot for cracking competitive exams and even board exams, my dear. So use my code RITESHLIVE for a subscription, and even get 10% instant discount by applying that code. Okay. RITESHLIVE. Okay, so that is a code for a subscription for a discount in the subscription. Okay, all right. So hope everyone will join as soon as possible. Done. Next, we have different plans like 1 month plan, 3 month plan, and even 6 month plan. 1 month plan, a 6 month plan, and 12 month plan. 1 month plan at 2250, 6 month plan at 11,250, 12 month plan at 13,750. So these are the different plans we have for you guys. So hope you will subscribe as soon as possible for the Unacademy Plus, and you can get all the beneficiaries which are there, which are given here, like structured live courses, dedicated live doubt clearing sessions. Uh, and See, these are the beneficiaries we give for the students. Okay, it done. So today's session is all about capacitors and resistors. So I will discuss both capacitors and resistor in a single session. Okay, so it will clear your confusions regarding capacitor and resistor. So there is a small difference in capacitor and resistor in the equivalent capacitance and equivalent resistance, right? So you know the formula for capacitors. For capacitors, what is the formula? That is Q is equal to C into V, right? So this is nothing but Coulomb's law, right? Okay, Coulomb's law. Okay, so how you get the C equivalent here? We have two conditions, that is one is parallel and other one is what, a series. So when system is parallel and when system is series, okay. So two conditions like parallel and series. C equivalent when it is parallel, what is the equation? Yes, when it is parallel, C equivalent is C1 plus C2. Similarly, when it is in series, C equivalent will be 1 by C1 plus 1 by C2 whole inverse. Alright, so this is the equation for capacitors. Similarly, we have equation for resistors. So there is main equation is V is equal to I into R. Right. So this is from Ohm's law in resistors, right? Okay, my dear. So what is the equation here? C not C equivalent, here it is R equivalent. So I need to write R equivalent, not C equivalent, right? Okay, so let me write R equivalent. So R equivalent when parallel and when it is in series. So R equivalent when it is parallel, then 1 by R1 plus 1 by R2 whole inverse. Alright, when it is in series, R equivalent is R1 plus R2. See, compare these two capacitors and resistance. See, when they are in parallel and when they are in parallel, only the difference is um, matching up of what variable is different. So how they addition, how they do it, adding up, right? So like when they are in series and when they are in series, so interchange vice versa. Okay, so I can write here vice versa. That's it. Okay, so what I do is here I will solve one numerical from capacitor, and similar exact copy of that numerical I will take, and I will change in place of capacitor I will write resistor. Okay, so what the equation will, sorry, how you are going to solve that, that is the thing. Okay, don't make any confusions regarding that. So let me start whether I need to derive it, that is C equivalent is equal to C1 plus C2, R equivalent is equal to R1 plus 2 R2. No, right? Okay, I will derive for R this resistance, because C equivalent anyhow I have derived in the previous sessions, but for R equivalent I have not derived. So I will derive first condition I will take, like when it is in parallel resistance. Okay, so keep an eye, very simple to solve it. Okay, so when they are in parallel, then I have to write figure resistance 1, resistance 2 and resistance 3, right? Then it is connected to battery. Is it right? Okay, made it. Then I have to name it like R1, R2, R3. So here we. So what is the concept? You know the concept, right? So concept says which color I will take. Okay. Concept says when current I flows, okay, so it will distribute like this, that is I1, I2 and I3. Current will be different, I will be different in the parallel resistance. Okay, voltage will be same. So voltage in this and in this and in this circuit will be same, because plus is connected to here and negative is connected to all the three spots, right? So that is V will be same. So what I do, I will going to derive it now. So like we have from Ohm's law, V is equal to I into R. Okay, so I is different, so I can write I equivalent will be, not equivalent, I net will be, yes, I net will be what? I net will be I1 plus I2 plus I3, right? So in place of I1 I can write this equation, that is I is equal to V divided by R. So V divided by R1 in this resistance, R1 resistance, V is same all over the three resistors, plus V divided by R2 plus V divided by R3, alright? Okay, so that I can write here also V divided by R equivalent. Okay, so that is V divided by, okay, V divided by R equivalent. So V get cancelled all over. Remaining is 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the equation for R equivalent when they are in parallel. Similarly, you can do when they are in series. When they are in series, you need to change the figure, like first resistance, second resistance, third resistance. Okay, so R1, R2, R3. So here current across all the resistors I will be same, this concept, but V will be different. Here it will be V1, here it will be V2, and here it will be V3. So I can write V net is equal to V1 plus V2 plus V3 for this. Then substitute this equation, that is I into R equivalent, that is equal to I into R1 plus I into R2. Why I? Because current will be same, plus I into R3. So I get cancelled all over. Remaining is R equivalent is equal to R1 plus R2 plus R3. So this is what I told in the previous. Okay, so this is the derivation. That's a simple derivation. So hope you understood, my dear. Aegis Smarty, hi, good evening. Okay, so that's it. Okay, so let me take a similar type of numerical, one from a capacitor and one from a resistor. Okay, first I will take from resistor. Okay, so one second, I will take the example. Hmm, let me take the example of a resistor. Okay, so this is the circuit. Okay, so this is the circuit, and it is connected to a battery. The voltage they have given, how much? Battery voltage V is equal to 2.4, and resistance here it is 4 ohm, and here it is 3 ohms, and here it is 6 ohms. Okay, so what you need to find I1, I2, I3, and also R equivalent. Okay, so here actually V is equal to I into R. Voltage anyhow you know, I you need to find. When it is in parallel, current I will flow. Okay, charges on each capacitor, each resistors, not charges, current on each resistors. So if you take this as R1, then current through it here is I1. Similarly, if it is R2, then current through in R2 is I2. Similarly, I3. Okay, so start solving it. Very easy concept. How can you find R equivalent? So first go for these two. Okay, that is R2 and R3. So what is the combination result for R2 and R3? That is nothing but, when they are in series, I have to write R equivalent is equal to 1 by 3 plus 1 by 6 whole inverse. So or else you can directly write multiplication over addition, that is 18 divided by addition is 9. So I get R equivalent as 2 ohms here. Okay, so then it is 2 ohms is connected to 4 ohm. A new circuit I will write um, like this. Okay, after the solution. So here I need to write 2 ohms, and here it is 4 ohms, here it is 2.4 volt. Okay, so combination of these two, that is R equivalent will be direct plus, right, when they are in series. So 4 plus 2, that is 6 ohms. So R equivalent is 6 ohms. R equivalent is 6 ohms. So this is the first answer. Okay, then I need to find current all over the resistors. So for that, first I need to find I net here. Okay, I net. So how can I find I net? Simple. So I net is nothing but V is equal to I into R, you know the equation. So I net is equal to V divided by R equivalent. Okay, so V how much? That is 2.4 divided by R equivalent. R equivalent I found from the last answer, that is 6. So I will get answer 2.4 divided by 6. How much? 2.4 divided by 6. Go for the calci. Uh, 2.4 divided by 6. So if you know the answer, please type there. So it is very helpful for me to get the answer quickly. System is too slow. 2.4 divided by 6. So that is how much? 0.4. So the answer is 0.4 amperes. Okay. So that is nothing but the current here. That is 0.4. So concept says current through here will be same R1. When they are in series, current will be same all over. Okay. So this is R1, right? So this is R dash actually, nothing but R2 and R3. Okay. So R1 in the place of R1 I can write I1. I1 will be same, that is 0.4 ampere. Okay, this is the another answer. But I got another, that is in place of R dash, that is nothing but I dash, that is also 0.4 ampere. But this is not the answer. I need to get I2 and I3, right? So here it will come 0.4 ampere, but it will distribute in such a way, right? So for that sake finding, I need to draw the voltage line here. So voltage will be same when they are in parallel. Okay. So V I need to find. V is what? V is equal to I into R. So I is 0.4 into R. R is R equivalent. These two, 3 and 6. How much? 2 I got. So that is 0.8 volt. Here also that is 0.8 volt. So then I will get I2 value. I2 value. I2 will be, okay, from this V divided by R. V divided by R2. That is V how much? 0.8 divided by 3. So I2 value how much I got? 0.8 divided by 3. 0.8 divided by 3, that is 0.4. 0.8 divided by 3, sorry, 0.8 divided by 3, 0.266, right? So 0.26 ampere. Okay, so you can directly write this value, like 0.4 minus 0.26 will be this. That is law of conservation of what? Charge. So here also I can find the same solution, like I3 is equal to V divided by R3, that is 0.8 divided by R3 is how much? 6. So 0.8 divided by 6. So how much I get? Again I have to go for calci. 0.8 divided by 6, that is nothing but 0.8 divided by 6. So 0.133, right? 0.13 ampere. So this is the another answer. Okay, so I got I1, I2, I3 and R equivalent. So that's it regarding the resistance. Okay, so you can add up 0.6 plus 26 plus 0.13. That will, you will get answer how much? 0.39 or 0.4. Okay, so that is incoming current. Okay, then it is distributed. That's it. So this is all about capacitors. So same question I will take in place of resist. Okay, this is resistors, right? So in place of resistors I will place the capacitor now. Then we will find charges and voltages, whatever. Okay, so okay, same question and try to find the answer. Don't make any confusions in the examination. Okay, not the resistor, this time it is capacitors, right? This is the new figure. From capacitors you need to find, that is V is equal to again 2.4 volt. Then they have given here is 4 microfarad, and it is how much, 3 and 6, 3 microfarad. Here it is 6 microfarad. Okay, so you need to find uh, C equivalent and charges on each capacitor. Okay, so that is nothing but Q1, Q2, Q3 you need to find. Okay, here we use Coulomb's law, that you need to like Q is equal to CV. Sorry. So system is running. Okay, so Q is equal to CV. You need to keep it in your mind. Okay, done. So how can I find R equivalent, C equivalent here? C equivalent when they are in parallel, so that is direct plus 6 plus 3, vice versa, right? So 6 plus 3, that is 9 microfarad. Okay, then it is connected in series, so new figure will be like this. Okay, so it is connected in series, so have to write this is 4 microfarad and it is 9 microfarad, series 2.4. Okay, when they are in series I will take C equivalent is equal to multiplication over addition, that is 9 for the 36 divided by 2.4. 2.4, right? Voltage, yes, 2.4. So what is the answer? 36 is not 2.4, sorry. R equivalent, C equivalent, right? Sorry. So 4 9 for the 36, 36 9 4 13. Okay, 13 ones are 13 3 is, so C equivalent will be 3 microfarad. Okay, so this is the first answer we get, C equivalent answer. Okay, so next I need to get charges Q1, Q2, Q3, Q everything, right? So that is Q net I need to find. There we need to find what? I net. Here it is Q net. Okay, so Q net is equal to C into V. So how you find? Q net is equal to C into C equivalent, that is how much you got? 3 into V, that is 2.4. So you get 24, 48, 58, 68, 72, that is 7.2 microcoulombs. This is coulombs. Okay, so I get 7.2 microcoulombs. Q, that is 7.2 microcoulombs. So this is the charge flowing through this. Okay, done. So then how can I find the next step after Q net? So Q charge will be same all over the capacitor when they are in series. So that is the concept. Okay, so charge over here will be same. This is C1. Okay, I need to take C1, C2 and C3, right? C1 will be Q1, that is Q1 will be 7.2 microcoulombs. So this is the another answer. Q1 I got, and even Q dash also 7.2 microcoulombs. Okay, but I don't want C Q dash, I need Q3 and Q4. So charge here will be 7.2 microcoulomb. It will get distributed. So voltage will be same. You need to draw the voltage line. V. How you get V value? See here. So V is equal to Q divided by C. So Q is what? 7.2 divided by C equivalent. C equivalent is these two, C2 and C3. Okay. So C equivalent of C2 and C3 is 9 divided by 9. So V value is 7.2, 7.2 divided by 9. So how much? 0.8. So this here V value is 0.8. Here also V value is 0.8. Okay. Then how can you find? Okay, you know the trick for that. Mm, in this capacitor you need to find C2, right? So what you need to find? You need to find charge. Q is equal to CV. So direct multiplication. C is, so Q2 will be C3 into zero point 0.8. So that is nothing but 2.4 microcoulombs. So that is another answer. Okay. Similarly here Q3 is 6 into zero point 0.8, 8, that is 4.8 microcoulombs. So that is the another answer. See, compare. Here it is 7.2. It is getting diverted. Law of conservation of charge distributed. So when combine these two, 2.4 and 4.8, then you will get 7.2. This only 7.2 microcoulombs. Okay. So when they come here, again they will add up. Then they will move. Again here it is 7.2. So whenever there is a capacitor in series, then you will get 7.2 microcoulombs. Okay. So this is the answer. So hope you got the concept of both capacitor and resistor. So I can try answer for trying getting answer for both, right? Okay. So please look at the uh, solution. Then I will tell some trick. 1 minute. Yes. So this is all about capacitors and resistors. All right. Okay. So hope you don't have any confusions regarding capacitors, combination of capacitors and combination of resistors. Right? So you can solve the things uh, easily whenever you have in the board exams they give one question from resistor and one from capacitor. The thing is you need to remember those formulas. If you forgot means you can directly uh, get the formula by using these tricks. Okay, so ಈ ತರ tricks ಅನ್ನು use ಮಾಡಿದ್ರೆ then you will get the R equivalent is what for a series for capacitor, that thing. So main two equations, what are the main two equations? Main two scientists, one is Ohm's law and other one is Coulomb's. Okay, so Ohm's law states V is equal to I into R and Coulomb's states Q is equal to C into V. So these are the two formulas you need to remember. Okay, so in the upcoming session I will solve some MCQs from resistors. Okay, so around 30 to 40 MCQs I will cover within 1 hour. I mean 2 sessions. Okay, after that I will go for Kirchhoff's law. So very important rules, Kirchhoff's law, that is current law, Kirchhoff's current law and Kirchhoff's voltage law. So these two are the very important rules you need to remember. So these two will be discussed in the upcoming sessions. Okay, so thank you for joining everyone. Have a great time. So hope you will be present in my upcoming sessions. Thank you everyone. Have a great time. Bye bye. Love you all.